Hi, my name is Nicolas Hervé. I'm going to present to you our paper on using ASR-generated text for spoken language modeling. This is a joint work between four labs from Institut National de l'Audiovisuel, the French Audiovisual National Archive, to universities, Le Mans in France and Aix-Marseille also in France, and Naval Labs Europe. Language models that are generally available do not reflect well the spoken language because, generally speaking, they are trained on written text. And our purpose here is to use a huge amount of automatically transcribed speech in order to train or to retrain new models. For this, we use a huge amount of TV and radio shows broadcasted in France, and we use the generated text through our ASR system in order to fine-tune or retrain an existing language model. In this preliminary work, we are going to evaluate these new models on both word prediction and also two downstream tasks. Modeling spoken language is quite challenging because of the availability of training data. Unlike what's possible with written text, crawling oral style transcript is quite difficult and it's not really an option because there are not much corpus available online. So instead of crawling this data from online sources, we're going to use what's broadcasted on TV and radio and to extract the text through an ASR system. Our experiments is done on the French language and as a proof of concept, but could be easily reproduced in other countries or with other languages. There are differences between written text and spoken language, and these differences have been studied through the existing language model to see the way they encode specific properties of spoken language. This is the case, for example, of the work of Kumar that study the BERT language models, and they conclude that these language models are able to capture conversational properties, even though they are trained on the non-ASR spoken transcript, but very clean transcripts. All these models, generally speaking, are trained on written text, except ASR Roberta, which has been trained on 2000 hours of transcribed speech. In our case, we are going to train our models on a huge corpus, much bigger than the one used for ASR Roberta. The ASR system that we use is based on Caldi. It has been trained on some French corpuses, and the vocabulary is 160K frequent words that are present in these corpuses. This system uses an automatic speech diarization that is based on a toolkit developed by a member of the team. The output of this ASR system is a speech segment without punctuation and without capitalization. Our corpus is composed of French TV and radio shows during 7 years from 14 stations. They were transcribed and are mostly news segments. In total, we have 350,000 hours of speech that have been transcribed, producing almost 20 gigabytes of generated text. The model we're using as a setup is Flaubert, which is a BERT model adapted for French that has been published 2 years ago. The Flaubert team provides several models. We are going to use Flaubert-based uncased model as a baseline, from which we are going to derive several other models. We choose this one because it has been trained on uncased text, and this is also the configuration of our ASR system that is producing only uncased transcripts. The first model, Flaubert Oral Base Uncased, is a simple fine-tuning of the existing model with our ASR text. Then for the three other models, we are retraining completely from scratch the Flaubert model. Using different type of corpuses for the training data. The first one is Flaubert Oral Mixed, for which we are going to use both ASR text and also written text. In this case, we are also using data from newspapers, from online news website, and also Wikipedia dump. and French text, of course. Then we are going to have two purely oral model, Flaubert oral ASR. And the difference between these two models is that they are trained only on our ASR text, the one we transcribe, but we are varying the BPE tokenizer. In one setup, we are going to use the tokenizer that is the one provided by Flaubert Bayes and Case. So this is our oral model. And we also try to retrain the tokenizer on our corpuses, which is the oral with the new BPE. So the first test that we made on these new models is to have a word prediction experiments. We've done that both on the training corpus and also on some other corpuses that we gather specifically for that. We wanted to test this model on some specific corpuses composed of either purely written texts. So we have AFP dispatches, which is AFP is the French news agency, and also on transcript. The second corpus is composed of manual transcripts of the French National Assembly sessions. And these are manual transcripts of what is said by the MPs, knowing that, generally speaking, what is being said is text that is prepared by the MPs. So we have partly prepared oral sessions and partly spontaneous speech. The last corpus came from the INA, where we have both educational and interviews. And for these videos, we have a very clean manual transcripts. And also, we have used our ASR system in order to transcribe these same videos. So for this corpus, we have both automatic and manual transcripts. So we have here the results of the word prediction and on the different datasets. On the AFP datasets, we see that the best performance is obtained with the mixed model, and this is mostly due to the fact that we included AFP dispatches not from the same year but previous years in our training dataset. So we believe this is one of the reasons we have this huge increase in performances. For the parliamentary session, we see that the original Flaubert Bayes and Case model is the best, and we are not able to improve the results on word prediction with using oral data. But for the videos that we have at INA, interviews and educational videos, we can see that here the fine-tuning of the existing model improved clearly the performances on the word prediction. So now that we have 4 new models, we are going to test them on 2 downstream tasks. The first one is a text classification. We're going to use the TV shows and the news broadcasts and trying to automatically classify in 14 categories these shows. The second one is to use the models in a standard learning setting for syntactic analysis of spoken conversations. So here at INA, we have documentalists that both segment and annotate all the news. And in this annotation, we also find a classification in 14 categories. These are quite standard categories such as politics, sport, international justice, health, science. And we're going to use 4 TV channels for which we have this classification. And we're going to use 3 years that we have in the dataset. In the final, we have almost 50,000 short TV shows, and these shows have, in average, 1.5 minutes. And the classification we are going to conduct as a baseline. We use a simple SVM with a TF-IDF vector representation for this data. And then we are going to test all the Flaubert model. And for that, we're going to use the transformer library from Hugging Face with a sequence classification class. What we wanted to observe is simply the difference between the models, and so we just train for several epochs this classification model. We didn't try to do early stopping or whatever. We just want to observe the way the model behave. So what we can see here is that we trained the model for 10 epochs on almost all the data set, and we keep a small amount of data, only 5K for the testing. And so we have the oral model, which is the one that is trained on purely on the oral corpus. That is the one that performs the better and from the start. And then we have here FBU is the original Flobat model based in case, the one that is trained only on written data that we have here. And we can see, generally speaking, an improvement in 2 points in F1 measure. And we can see generally speaking, the improving performances over the simple SVM. We also wanted to test these models in another configuration, like a few shot settings, where we use only 2000 example for training, and we test on the rest of the dataset. So these experiments have been done 10 times, and the average is presented. The average results are presented here. And here we can see that again, the oral model is the one that performs best, and even though the other ones are not so far. And here again, we have a 2 points increase between the oral model and the Flobat Bayes and case model. The second downstream task is syntactic analysis of spoken conversations. This is a parser that jointly predicts part of speech tags and dependency trees. For that, the experiments are conducted on a dataset called Orfeo, and it has manual transcripts of French spoken data, which are mostly dialogues, and also the part of speech and the syntactic dependencies that have been manually annotated. In the experiments that we have done, our models are compared, and we use several setups. So in the first one, we randomly initialize the word embeddings, and we also compare with a non-contextual embedding, the one from fast text, and then the one from the Flobat model. Here we have the results using the 3 different metrics for labeled and unlabeled attachment scores, and also part of speech tagging accuracy. And we can see that for these 3 metrics, the model that perform best are the 2 oral models, either with the new BPE or the original BPE tokenizer. So what we've shown here with our first results is that learning spoken language modeling using purely ASR-generated text is something that is possible. And of course, this model are shared. They're available on the Hugging Face hub. And this model generally are better than the initial Flobat model trained purely on written text for our specific tasks on speech corpuses. These are preliminary results, and we still need to extend our research to more downstream tasks on speech corpuses. And we also need to check a little bit better the performances on text tasks to see whether we are able to have really generic models that model both well both written and speech texts. And finally, we also need to evaluate the impact of the tokenizer, because we've observed in our experiments that these BPE units have an influence on the result. Thank you for your attention, and we'll be happy to answer any question you may have on this work.